Welcome to Chapter 9, Chemical Reactions. To this point, everything you have learned has been getting you ready to start real chemistry. So you have your foundation, you have your knowledge base, and now we are going to start chemical reactions. There are 5 different types of chemical reactions, and on Friday we're going to do 5 different demos, and you're going to get to see those in action. But first, what is a chemical reaction? A chemical reaction is when you have one or more substances that are rearranged to form a new, different substance. i.e., you have your reactants that rearrange to give you your products. How do scientists know if a chemical reaction has occurred? Let's look at some possible indicators. First, if you see a change in temperature, such as the absorption of heat and release of energy in the form of light or heat. Second, if a change in color is noticed. Thirdly, if gas, such as bubbles or fizzing, or a solid is noticed, a chemical reaction may have occurred. How do scientists represent chemical reactions? Well, they can do this in 2 ways, word equations or skeleton equations. For example, if you had some aluminum and some bromide and you were to react it together, you would produce aluminum bromide, and you could represent it by writing out the words aluminum solid plus bromide liquid reacts to make or produce aluminum bromide. Or you could use a skeletal equation and write out the symbols and the element symbols. A chemical reaction can be written into a statement, and a chemical equation is used to represent chemical reactions, where you have the reactants, the starting substance, and the products, which are formed during the reaction. They are written with an arrow from left to right called a yield sign. So for example, if you had some hydrogen plus some oxygen, you would yield H2O or water. Also notice that a plus sign is used to separate the different reactants and products. And the symbols S, L, G, and AQ are represented as you see in this chart, a solid, liquid, gas, and aqueous. Notice the double arrows means that separate reactants from products can go in the reverse direction. Does anybody remember what Lavoisier has taught us? The conservation of mass, meaning that matter can neither be created nor destroyed. In a balanced equation, you'll notice that the skeletal equations before didn't represent that all the matter was conserved, and we know that matter is not created or destroyed. So, we are going to add coefficients to help balance the equation. Whatever your reactants are that you start with, you must also have in your products. To balance an equation, you will write the coefficient, which is placed in front of the atoms. For example, let's count how many aluminum we have in our reactants. We have 2 silver balls, 1, 2, and how many bromide? The bromide are the orange balls. And notice that the bromides are diatomics, so they exist where the 2 bromides are connected together, forming a pair. We have 2, 4, 6. And on our reactant side, we have 6 bromide and 2 aluminum. We see that the law of conservation of matter is observed here. You have the same amount of aluminums, 2 on each side, and the same amount of bromides, 6 on each side. This brings us to 3 important reminders before we learn how to balance equations. The first is the law of conservation, which we've talked about. The second is that a chemical compound with subscripts are not to be altered. Remember, they're a family. A compound stays the exact ratio that it already is written in. Also, diatomic elements come in pairs, such as hydrogen, bromide, oxygen, nitrogen, chlorine, iodine, and fluorine. There are 6 steps to balance a chemical equation. First, you're going to write the skeletal equation. The second step is you count the atoms of the elements in the reactants, and any polyatomic ions that remain unchanged can be counted as if they are elements. Your third step is you're going to count the atoms of the elements in the products. Step 4, you'll change the coefficients to make the number of atoms of each element equal on both sides of the equation. Remember, don't change those subscripts. Step 5, you will write the coefficient in the lowest possible ratio. Step 6, check your work.